This is R.D. Sharma Solution Class 12, Chapter 8, Solution of Simultaneous Linear Equations. Exercise is 8.1. Show that each one of the following systems of linear equation is inconsistent. So it's a different kind of question because you can say one option is used when the determinant A is 0 or not 0. So first we will do what? We will write this in matrix form because we are solving using matrix. So Ax is equal to B. What is A here? The coefficient of x, which is 2, 6. Coefficient of y, which is 5 and 15. This is your A. What is x here? X is x and y. What is B here? It's 7 and 13. Now, first of all, we'll try to find out the determinant of A. So 2 into 15 minus 5 into 6, you get 30 minus 30, that is 0. Now, since the determinant of A is 0, when it was not equal to 0, then we have some consistent solution. But when determinant of A is not equal to 0, and there can be two options now. Consistent with infinite solution and inconsistent. That is, if you have a line and they are same line, or if the line are parallel, they will never intersect. Then the next step is finding out the adjoint A into B multiplied by B. Now when this also comes to 0, determinant A came 0, then adjoint of A dot B equals 0, then we say that we have infinitely many solutions. But if the determinant of A is equal to 0 and adjoint A into B is not equal to 0, then we will say inconsistent. These equations are inconsistent. Because in the first case, they are same line, almost similar. But if you see consistency with a proper solution, single solution, you have a single solution. They are intersecting. What is adjoint? Let us find adjoint. So I'm exchanging 2 and 15 and changing the sign of 5 and 6. So this is your adjoint. And we have to multiply it by B, which is 7 and 13 in this case. So 15 into 7, which is going to be 105, minus 7, 5, this 5, 15, 5 and 5 and 13. Then minus 6 into 7 and then 2 into 30. So you get 105 minus 65 here. And then that is going to be 40, and here you have minus 42 plus 26. So 40 and minus 16 will come, and that is not equal to 0. This is not equal to 0. So as I said, when it is not equal to 0, that means it is inconsistent. Inconsistent, right? Now you know how to do this. So first of all, you have to write it in the form of AXB, then determinant of A. If it is 0, then try to find out adjoint A to B. If it is not equal to 0, then you can safely say that this system of equations are inconsistent. Show that each one of the following systems of linear equation is inconsistent. So I'll just go ahead. All this we have done. Show that each one of the following system of linear equation is inconsistent. So there are three equations. So first thing is that we are solving it by matrix. So Ax equals B. And in order to find out, the first thing is A. So I'm writing the coefficient of x, coefficient of y now, and coefficient of z. And this is going to be your A matrix, right? And then what is going to be x? It is going to be x, y and z because there are three variables. And this is equal to B, which is 2, negative 2 and negative 1, right? Now see, determinant of A we have to find out. Let me revise it for you. See, the determinant of A is 0 or not. If the determinant of A is not equal to 0, you will get solution, it is consistent. But if determinant of A is 0. If you're not equal to 0, then as I said, we already solved this type of questions. But determinant of A, if it is equal to 0, then what you will do? Adjoint of A into B you will find out. So adjoint of A and B, that is adjoint of A into B in both the cases, one time it may come as 0, one time it may come not equal to 0. So when it comes to 0, then you will say that since determinant of A is 0, this is also 0. So we have infinitely many solutions and the system of equations are consistent. It is consistent, but since we have infinite solution, we will say that it is consistent. But here, if the determinant of A is 0 and adjoint of A multiplied by B is not equal to 0, then what we say? We say it is inconsistent. The given equation of our system of equations are inconsistent. So let us go ahead with this question. We have to find out the determinant of this particular matrix. So determinant of A will be equal to, so I hope you'll be able to find it out, it is 0. So determinant of A is 0. Now we have to go to adjoint A into B. So we have to take the cofactor, then cofactor matrix you have to write, and then take the transpose, and that is going to be adjoint A. Let me write the adjoint A directly here. It's like these numbers are not important. The concept is important. Because if you know the concept, any equation, any number, you can solve it. So I'm writing adjoint A here, and I'm going to multiply this with the B matrix. What is B matrix? It is 2, -2 and -1. So the final result is not equal to 0. This is 2 minus 126 and 63. This is not equal to 0. So we can easily say that these linear equations are inconsistent. So what do you say? Because determinant of A is 0, but the adjoint A into B is not equal to 0. Inconsistent. Same thing you have to do here. Show that each one of the following system of linear equation is inconsistent. Just see here that let me just write this A matrix. So 3, 1, minus 1, -2, then x is 0, y is 2, and then we have -1, then x is 3, y is -5, and z is 0. So this is your A. Now determinant of A you have to find out. If it comes to 0, well, in this case it will come to 0. Then there can be two cases, whether adjoint, let me write it here like this. Adjoint A into B you have to find out. It can come as equal to 0. It may come not equal to 0. If it comes to 0, then we say that it is consistent, but it has infinitely many solutions when we both are going to come as 0. So infinite many solution in this case. But if determinant of A is 0, but the adjoint of A into B is not equal to 0, then you will say these systems of linear equation are inconsistent. So adjoint A, the cofactor matrix, transpose of that cofactor matrix is adjoint A, multiplied with B, which is 2, minus 1 and 3. It will not be equal to 0. So these are inconsistent. So inconsistency you know now. So same way you have to go ahead with this. Please remember, determinant of A 0, adjoint A into B not equal to 0. Determinant of A 0, adjoint of A into B not equal to 0. That means the linear equation or system of linear equation inconsistent. Determinant of A 0, adjoint of A multiplied by B equals to 0. That means the system of equations are consistent with infinitely many solutions. Now next one, A and B. These are two square matrices. So first we have to find out AB, and hence that means using this AB or solution of this AB, we have to solve this linear equation. But if you observe these equations very closely, you'll see x minus y equals 3, 2x plus 3y plus 4z equals 17, and y plus 2z equals 7. So what do you get here? You get a system of linear equation, and if I take the or write the A matrix for these three equations, wherever the values are not there, I'm putting 0. So when I make a matrix Ax equals B, for example, what will be A in this case? 1, minus 1, 0, 2, 3, 4, and 0, 1, 2. Now, this is A matrix which is given in the question as well. So, same matrix is given, and these linear equations or these equations are giving us the same matrix. So, eventually, this A will be same as these. So, what we have to do? We have to multiply A and B, and once we multiply, you will see that it will be a scalar matrix. You multiply A and B, it will be a scalar matrix, and 6, if you take outside, it will be 6 into identity matrix. Now, the case is A, B, just as a linear algebra point of view, this A inverse can be computed here. So what you can do here is, you can divide both sides by 6. It can be A by 6, it can be B by 6. So why not to give it B by 6? Because we are interested in A inverse. Okay? Because A is eventually 6i by B. If you take B in the denominator, A inverse, let us invert it. It will be B inverse by 6i, that is 6 only. B by 6. A inverse is this. Okay. Now, if you want to solve this using A inverse, so A inverse is this. X is A inverse into B. What is B here? It should be 3, 17 and 7. But since we have to use this A inverse to solve these equations, so we'll use B as the 3, 17 and 7. B is not what this is given, okay? This is just B by 6. So B is matrix, will take B by 6. B is actual matrix we are taking, divided by 6. And the B in this case is not that B which is given as matrix, which we have found out, 3, 17, 7. And then we multiplied this. So what do you get? X, Y, Z, these are the values. This is how we are going to solve it. This is A, we have to find out A inverse and also to solve these equations. And when we actually observe and go deeper to these equations, you will eventually see that these equations are nothing but the matrix which is given. So 2 minus 3, 5. I am taking now 3, 2 minus 4 from the equation. Then 1, 1 and 1, 1 and 2. This is your A matrix. Now A inverse, so you have to take the inverse of this matrix. I hope you will be able to find out the A inverse, because X is equal to A inverse B. A inverse, we have to find out what will be B. Let me write it here. It is 11. I'm writing B now. 11 and negative 5 and then minus 3. So just take the inverse of this A, multiply it with B, and you will get the solution. So A, first you have to find out determinant of A. It is not coming as 0. So you will get some solution, XYZ precise solution. So now you have to find out the cofactor matrix of A. Then take the transpose. And then when you do this, divide it by adjoint of this determinant of A. So now this inverse has come. Multiply it with 11 minus 5, 3 minus 3. XYZ will come. Find A inverse if A is this. Hence solve the following system of linear equations. These are three equations: x plus 2y plus 5z equals 10, x minus y minus z equals minus 2, and 2x minus 3y minus z equals negative 11. So I am writing the coefficient of x, y, z in order to find out that A called matrix. So I am just writing these 2, 3, negative 1. This is the matrix already given to you in the question only. What is B? 10, negative 2 and negative 11. So find in A inverse. Of course, you have to find out the A inverse. You have to find out the adjoint of A divided by the determinant of A. You will get the A inverse. And X equals A inverse B. A inverse multiplied using 10, -2 and -11. And what do you get? You'll get the solution. Just see here. A is this. Determinant of A is equal to 0. Then there will be two cases. But determinant of A is not equal to 0. So you'll get a precise solution. Consistent and precise solution. So cofactor matrix you can find out. Take the transpose of cofactor matrix. Then divide it by using the determinant, which is 27 in this case. A inverse will come. Now A inverse has to be multiplied by B. What is B? B is 10, -2 and -11. Multiply this, you will get X, Y, Z. In this case, -1, -2 and 3 will come. Same thing here. A inverse, using A inverse, you have to find out the solution of this equation. Same thing. I'm just going forward now. So A is equal to this, and let me just give you the constant values here. See, 8 question has certain parts here. I don't know which edition you are using. You will find out which question actually is there in your edition. So I'm making the equation. It is basically 3x minus 4y plus 2z. And 2x plus 3y plus 5z, x plus 0y, you can leave 0 plus z, and this is equal to, what is the constant value? I'll just write it here. It is -1 and 7 and 2. So what you have to do is inverse. I hope you'll be able to find out, and multiply this inverse with this -1, 7, 2, and inverse multiplied with this matrix, which is B, and you'll get X, Y, and Z. So A and B, same thing you have to do. So the equations are also given, and the coefficient of equation is nothing but A matrix only. And since we have already seen a question like this, let me write the B which we use in A, X equals B, which is, this is B, not B that is given in the question. So 10, 8, 7. And this A, B, when you multiply this, you will get a scalar matrix. So 11 you can take out. It will be, AB will be 11 into I. And in order to find out this A or A inverse, that will be B by 11, as I told you earlier also. Now take B, which is given in the question. Divide by 11, and now multiply this with 10, 8 and 7. So when you multiply with 10, 8, 7, you will get the proper values, which is X equals 4, Y equals -3 and Z equals 1. I hope the concept is clear to you, because the B which is given in the question is not what we are intending in the B which we are finding or we are giving.